Hi guys. Now today I'm going to talk to you about procs and arrays. So first of all, I create a constant here. This is how we create constants in Massum. You just say the name of the constant. The tradition is all caps and equals the value. By the way, it doesn't have to be a number. You could put a string or any combination of letters in there, and it will use that. Uh, you can do really exotic things that way, but don't. Usually we use numbers or strings. Now, this is how you set up an array in the static data, which is one of the two ways to set up arrays, and the only way I'll probably have a chance to teach you, which is you say the name of the array, the type of the array. In this case, it's an array of ints, uh, and then you have the size of the array, which I used array size for here, and then I you say dup, and you can initialize the array by putting something in there, but I'm making it an uninitialized array, so it'll put in question mark. Now, this array I'm not always going to fill, so I'm also keeping track of the actual size of the array. So the array can be 10, but I'm going to let it be less than 10. So I'm going to be able to read less than 10. So I'm going to keep the actual size of the array over here. Now, so now we get into procs. Uh, okay, so I wrote this proc. Let me just start with the simpler version. I wrote this proc called output array. Okay, I say uses and give a list of registers. I'm going to use EAX, ECX, and EDI as the registers I'm using in this guy. And I have two variables. Notice there's no commas in this part. You put the name of the array, the name of the proc, and uses. Okay, that way these registers, by the way, are restored after you invoke the proc. We'll talk about invoking in a second. Here we have two parameters. To output is the array to output. And I say it's a location of an SD word. That'll be the location of the first SD word in the array. And the size is an SD word, is an int. Okay. Now the proc ends by saying output array NP. You need that, or bad things are going to happen. So you need a proc, and an NP is the end. And both of them start with the name of the proc. Now I have a local variable here called array index. So this is how I create a local variable. It's also an int, and I'm going to use that to index the array. So I'm going to start with the array index as 0, and I'm going to uh, put into EDI to output. Now, you never want to, you want to have the array location, that is, to output is the location of the array. That's what that pointer means, PTR means, into a register, because you can't access memory twice. So if you're going to put something in the array, you want that to be in a register. So I'm moving E2 output to EDI. You really, whenever you use this kind of thing, the location of something, you want to move it into a register, and usually I use either ESI or EDI. Now, you can use ECX, EAX, EDX if you want to. There's no, these are just traditions. Now, what we're going to do is the first thing I'm going to do is output the array index. And here you see me just outputting this local variable. You can treat it just like a static variable in this case. The only thing is you can't access it outside the proc, but I'm sure you're used to that. We're also notice that I'm using, I don't use loop because that's going to get me in trouble or repeat or anything. I put the name of what I'm doing into the label. That will save huge amounts of trouble later on. Now, so I output the array square bracket array index. I move the array index into a register because once again, array index is a memory, and if I want to access memory with it, I needs to be in a register. So ECX gets array index. Now, EDI plus 4, that's the size. Okay, the 4 is the size of a SD word. 4 bytes, because this is a 32-bit number. So we're going to index by EDI, that's the location of the array, plus 4 times ECX. If it was an array, a string, an array of bytes, it would be 1 time ECX, but now it is 4 times ECX. And we can, and that's how, and this is how we access an element of the array, and I'm going to move move that into EAX and output it over here. And then I put a new line. I increment the index. I got to move the index back into ECX because I can compare with array size. This is the other parameter, right? To output is one parameter, array size is the other. I'm going to compare, and I can't compare two memory locations to each other, so I move it to ECX in a register. I compare that register to array size, and if it's less, I jump to the output loop, and otherwise I'm done, and I do return. You got to do this at the end. You can't forget this. You got to do this at the end of every proc, or bad things will happen. Assembly will not protect you. It will simply start, it will go to the next line of code, whatever that might be, which is almost never what you want it to do. So you want to make sure that every time on every path you do ret in a proc. That should be the last thing you always do in a proc, unless you're writing an infinite loop or something weird like that. So that's output array. Read array is sort of similar. The only difference is input size now is a reference. It's the location of input size, so I can change it. So if I want to change a value, I've got to pass the location of the input size rather than the output. So what I did is I passed the location of the array and the location of the input size. Otherwise, I do very similar stuff. I have this local array index. I go through, I output the array index, I get the number from the user, and I see if it's a terminator. If it's a 0 terminated array in this case, I go to array done, and and this time I move array index into ECX. Once again, I can only have one of those guys. Once again, I do 4 times ECX to indicate that because it's an array of SD words, and I increment the index. I see if the array is full, and I output. And now, how do I call these guys? I invoke. Uh, Actually, I don't need that. That was debugging lines. Let's get rid of those. I invoke read array with the location of the array and the location of the size. I invoke output array, but this time I only give the location. Offset means the location of the array, and the value of the size, the number that is the size, because, and I can run this program. Now it doesn't do anything very interesting, well, but I gotta remember, oops, I forgot to save it. Let me save it. Now, I keep forgetting to save it before I compile. That is one of the annoying things about this. Now I've saved it, and you see that's all at the same time. And let's run the program. And it's going to enter. I'm going to enter 2, 9, 3 minus 1, 4, and 0 will terminate. And you see it outputs 2, 9, 3 minus 1, 4. So this is all good. Now, the last thing I'm going to show in this is writing a new proc. So I'm going to write a proc called largest proc. And now, this is going to return a value in EAX. When I write a function, not a, it has to return. So I can't say uses EAX. It's going to use ECX, once again, for indexing, and EDI for holding the array. No commas in this part. And now I'm going to say that the name of my array is the largest array, and it's going to be a location, because we're not passing the number, we're passing the location, so we say pointer SD word. And then I'm going to also pass a, okay, so if I don't want, so arrays always got to be passed by reference. They always got to refer to. And I also am going to put in the largest size, and that's going to be just an SD word because it's just the size. So just like when I output. And I'm going to also write largest NP, and I also, whenever I create one of these, I say return to not forget to write return. Now, I'm going to have a local, which is going to be, notice that a lot of these macros here, a lot of these guys, proc, NP, uses, are all local, are all capitalized. And this is going to be, and this is actually going to be, returns the largest number in the array in EAX. So local array index, and that's going to be an SD word.